Okay, so when we're factoring by the GCF, looks like I'm missing part of my G there. When we're factoring by the GCF itself, what we find to be the greatest common factor, that GCF becomes one of our factors of that polynomial. And the resulting term, or terms, we should say, the resulting terms. So after we've done the dividing, there will be results. We'll have some terms that will be the results. The resulting terms after dividing each of them by the GCF becomes the other factor. So here's what happens with factoring. When you're done factoring a polynomial, what should hold true is if you had to, if I told you now multiply that, I told you to do the multiplication, take your GCF times your other factor that you have. If I told you to multiply that out, it should take you back to what we started with. So that's going to be like a way for you to check to see, do I have a good answer here? Because if you would do the multiplication and it wouldn't take you back to what we started with, there's a problem. Okay, so let's practice factoring this first one, 5b plus 9b cubed. So we're going to do just like we did yesterday. We're going to let the number parts, work together. We're going to let the variable parts work together, and we're going to find the GCF of the 5b and the 9b cubed. So what's the GCF of 5 and 9? 1. There isn't a number that divides into 5 that also divides into 9 other than 1. Okay? What do you think the GCF of b and b to the third power is? B. Hopefully you have figured out by now that one of those two is going to be the GCF of those guys. The one that there is the least of. So there's only one B, but the other one has 3 factors of B. Well, you can't divide 3 factors of B out of 1 B, but you can divide a B out of a B, and you can divide a B out of a B cubed. Okay, so the GCF then is, remember what do we do with those? We multiply them. 1 times B, what's our GCF? 1B. 1B. Or, this is how we would see it in an answer bank, just B. We wouldn't even have the 1 there. Okay, so next thing we do then is we take our 2 terms of our polynomial, our original polynomial, and we divide them by that GCF. So both of those are going to get divided by B, our GCF. So what is 5B divided by B?
5.
And maybe what some of you might be better for you to do this, write it like this, 5B divided by B as a fraction, because then if you write it as a fraction, you can see that what's going to happen here?
It's just going to, the B's are going to cancel out.
The B's are going to cancel out, and that becomes 5, doesn't it? Well, 9b cubed, 9b to the, oh, I gotta get somewhere where I have some white space here to work with. 9b cubed, 9b cubed divided by b can be written like this.
We need to subtract.
And what do we do when we divide b's?
Factors are the exponents.
Yeah, we got 3 of them upstairs and 1 downstairs. 3 take away 1 is 2. So 9b cubed divided by b, that 9 can't be divided by anything, so it's going to stay 9, and b cubed divided by b is b squared. I'm going to change that to being blue just to show here. Equals 9b squared. Okay? So now here's what we need to do with our results after we do the dividing. These they get added together. So 5 plus 9b squared. So we really have, after we've divided out our GCF, this is the result.
So it will be then you.
So the factor name of this polynomial is
14b squared.
not 14b squared. You can't add those together. 5 is not, those aren't b squared.
9b squared.
Okay, but what's the first thing we divided out? What was our first GCF?
5b.
5, no. What did we divide by?
1 for B.
B.
We divided by B, our GCF. We divided by B, that's our GCF. Note, what did it say up above? The resulting factor, the other factor will be the resulting terms after you divide by that GCF. Well, after we got done dividing by that GCF, here's what we had. So 5 plus 9b squared is what we had after we divided that b out. So this is now, we've taken this polynomial and we've factored it. How do we know if we're done if we have good factors? We would try multiplying it. So let me come over here and show you if we have good factors, a good factor name for this polynomial. If we did distributive property, it better take us back to what we started with. So what's b times 5? 5b. What's b times 9b squared?
9b cubed.
9b cubed.
Oh, that's neat.
Does that take us back to what we started with?
Yep.
It does, doesn't it? So this is really our answer for today. That's our factored name. We're renaming the polynomial factor. And the reason that we have to learn how to do this is because it helps us solve equations that have polynomials in them. All our equations aren't always just going to be x in them. They're going to have polynomials involved, and we have to know how to solve them. So by factoring when we can, this is going to set us up for being able to solve an equation that had that polynomial in it. Okay? So any questions at the moment? Okay. So the first thing we're going to do is remember we're going to find the GCF of these two terms. So we're going to find the GCF of.
Do you add the opposites on these ones?
Okay, yes, that's exactly what my arrow is there for. 12x squared plus negative 8x. Okay, so we're going to find the GCF of both of the parts of this. So we're going to find the GCF of 12 and negative 8. And we're going to find the GCF of x squared and x. Because that's going to become the GCF of the whole polynomial after we bring it together, okay? So what's the GCF of 12 and negative 8?
4.
What's the largest number divides out of both of them? 4. Okay, so the GCF of 12 and negative 8 is going to be 4. What's the GCF of x squared and x?
X.
It's going to be x. So remember, what do we do with these two now?
Multiply them.
Multiply them. So we say, okay, 4 times x. And what does that equal?
4x.
4x. Okay, I want to do something a little bit different here. I want us to write down what we just actually found. We actually just found right now the 4x is, I want you to write this in your notes. 4x is the GCF of the polynomial. 4x is the GCF of the polynomial. Okay, so we're saying the largest monomial that you can divide out of both terms of that polynomial is 4x. Well, then now we got to find out what happens after you do divide that out. We're not just finding the GCF today. Now we're using the GCF to help us factor this polynomial. So the next thing that we're going to do is we're going to we're going to actually divide both of them by that. So we have 12x squared that is going to get divided by, so let's put this little note up here. I should divide both terms by 4x. squared is going to get divided by 4x, and negative 8x is going to get divided by 4x. So first thing, find the GCF of the whole polynomial. After you find that GCF, divide every term of the polynomial by it. So this is where we kind of like are trying to not show as much work. What's 12 divided by 4? 3. I just want to know what 12 divided by 4 is. That's all right. What's 12 divided by 4? 3. What's x squared divided by x? And that's x. Okay, I think what we should do though, so that we can see this better. Let's do that what we were doing up there. Put this in a fraction. I think you'll see the division better that way. So 12 divided by 4, 3. X to the second power divided by x to the first power, 2, take away 1, 1, right? So x. And then we're going to do the other one.
It's
So
easy when you put it in fractions like that.
Negative 8x, yeah, I think that probably will be easier for you guys.
Negative 2.
Negative 8 divided by 4, negative 2.
Do we have to do it that way? Because I'm getting it.
Yeah, if you can do it without the fraction, that's fine. And x divided by x? 1, right? Well, 1 times negative 2 is? Negative 2. Or in other words, we could say that these x's cancel out, don't they? Okay, so what are we going to do with these guys?
You're going to add them.
Add them together. This is, up here we're multiplying when we're finding the GCF. We're not finding the GCF anymore. We were dividing by the GCF, but we now take what we have as results and add them together. Here's where we add. So the factored name is the monomial GCF factor,
12x squared plus
which
negative
is,
8x.
oh wait a minute, we forgot something. The GCF factor, don't forget it,
4x.
4x times in parentheses 3x plus negative 2.
Wouldn't you clean that
And
up?
we'll clean that up, won't we? How would that look cleaned up? 4x times
3x, subtract 2.
3x subtract 2.
I didn't do that.
Here's our final answer.
I didn't do that.
You didn't get that?
No, but I got the right answer.
How do you know you got the right answer?
Because it equaled to like what was on top.
Because it multiplies out?
Yeah.
Okay, what answer did you get, Jesse?
I got 12x squared plus negative 8x. Oh, for that, just kidding.
No, okay.
Yeah, I got
For
the
your
same thing
factors.
you did.
Oh, for the factors, you got the same thing. That's good. Okay, this is really our final answer here, okay? This is the answer when they tell you to factor the polynomial. That's our answer. We have factored it. But if we want to make sure we have a good factor name for it, then we can multiply it back out and see if we get it back
So
to
we
where
don't
we
have to do
started.
that?
We don't have to multiply it
Oh,
back out.
well,
I'm
I'm
just
gonna
showing you that that's how you can check to see if you have a good factor name. Okay? Questions, concerns before we move on to trinomial?
Oh my gosh.
No? Okay. So let's go then to the back side and look at this trinomial one. Okay, what's our first move going to be? Find
Add
the,
opposite.
oh yeah, we gotta do that. 8x to the 4th. You guys are so good about remembering that. Add the opposite. Okay.
And find the GCF.
Okay, now we're gonna find the GCF. So let's make that little note here. Find the GCF of the polynomial. So in other words, we have 3 terms in our polynomial, so we have to make sure that whatever we call the GCF can be divided out of all 3 of them, and it's the largest.
2
thing that can be.
It's 2.
So let's write down here, we have 8x to the 4th. And we have, oh, remember, I've got to do it this other way. We have to find 8 and, again, I think of even how to do this, showing you guys how to show the work. So, yeah, we're looking for the GCF first of all, of the number parts. I'm so used to just doing this all in my head. GCF of 8, 4, and -2. So what's the GCF of the constant part, the number part? It's the largest number we can divide out of
2.
all of those. Probably 2, right? And we'll just make it positive 2. And now we need the GCF of the variable parts. So of x to the 4th, x to the 3rd, x to the 2nd.
Nothing goes
Really? No
And
GCF there?
1.
Huh. They're only all divisible by 1, huh?
Yes.
Well, let me go up here.
2.
No, 3, 2 doesn't.
Wait a minute, those are exponents, you guys. What does x to the 4th mean?
X
X
That's
times x times x times x.
Oh, so
X
X.
squared.
What does x to the 3rd mean?
I don't know, 3 of x.
3x is being multiplied. X times x times x. And what does x squared mean? X times x. So what's the most number of x's that can be divided out of all of them? X to the 2nd power. No, how can you take 4 x's out of x squared?
You can't.
You can't.
I
So
knew it was 2.
So it's going to be x squared, not 2. Is that what you
Same
said?
thing. That's what
X to the 2nd power. Remember, what did I say? It's going to be the one that has the smallest exponent on it. Because you can't take more out of that one than there are. So it's notice this is what should happen every time. It should be the one that has the smallest number of exponent. Okay, so now that means our GCF is 2 times x squared. So what's the GCF?
2x squared.
Okay, so the GCF is 2x squared. So it's going to be one of our factors in our final answer. But now we have to divide by that. So we're going to divide each term by 2x squared. Because we need the result. You know, the result that we really didn't use yesterday. We just divided until we found the greatest common factor. We didn't deal with the result. Today we're dealing with the result too. So we're going to take our 8x to the 4th and divide that by 2x squared, which you're sounding like you like it to be written as fractions, most of you. And we need the 4x cubed to be divided by 2x squared. If you want to just put it in a fraction right away, you could do that. Instead of writing out this multiplication or this division thing here. And then you have to take the negative 2x squared and divide by 2x squared. Okay, let's deal with the first one here.
4x squared.
What's 8 divided by 2? 4. And x to the 4th divided by x squared?
X squared.
X squared. What's in the next one? What's 4 divided by 2?
2.
2.
X.
What's x cubed divided by x squared? X. Are you starting to see why all these lessons that we did leading up to this were important?
We'd be completely lost.
What if we couldn't divide by powers, huh? Negative 2 divided by 2?
No, negative 1.
Negative 1. And x squared divided by x squared? They just cancel each other out, right?
0.
Not really 0. 1. Yeah, and 1 times negative 1 is negative 1 anyway. Okay. So now, what do we do with these three?
Add them.
Add them. 4x squared plus 2x plus negative 1. I didn't give you enough room?
No.
Oh, I'm sorry. Okay, and now we're ready to put our final answer. Answer. What's the answer look like?
5x.
No. 4x plus 2x plus negative 1.
2x.
Parentheses, you do the 8x to the 4 plus negative 4.
What are you talking
What?
I'm doing it the long
Haley?
way.
Okay, it was 2x squared, and then in parentheses, 4x squared plus 2x.
So confused.
Subtract 1.
How'd you get that?
Because we're factoring. Remember, the first thing we did was find the GCF. That is one of the factors.
Where'd you get the 2x squared?
That's our GCF. That's our first factor.
Oh,
So
yeah,
you might
don't
want,
listen to
you
me.
might want to, after you do that, you might want to circle that up there and say, don't forget me. Don't forget me in the answer, because I'm part of the answer. And then the other part of the answer is what's the result after you do the dividing? That's the other factor.
I get it now.
Okay? So there's our answer for that one.
The next one.
You know what next one's tricky? Okay. Anybody have any questions on this one before we do move on to the last one here? Okay, then let's try the next one. Okay, we need to GCF first. We need to find the GCF of the polynomial. The thing that comes down and it gets to be first in our answer. We need to find the GCF of the polynomial. So that means we have to find, first of all, we need the GCF of 3, 4, and, whoops, forgot to change it to add the opposite. Let's change it to add the opposite.
Oh, I did that
And
right away.
negative 2, right?
Wouldn't it be 1?
Because what?
Because nothing goes into them.
Yeah, 3 is a prime number, isn't it? What's true about prime numbers? What's the only thing that, yeah, the only thing that goes into prime numbers is itself and 1. And so then, but you can't stop there. You can't say, well, because one of them's prime, that means I can't do it. You have to take that prime number and see, can that prime number go into the other numbers? Can 3 go into 4 and 2?
No.
No. So we say the GCF of this group is 1.
Well, it can't be a fraction.
And then we have to GCF x squared. Now we're finding the GCF of x squared, xy, and
Oh my god.
y squared. Garcia?
Well, couldn't you just do it to where like you just find the GCF of like x squared and x and then y and y squared?
No.
Can't you
All
just
3 of them
combine
have to work together.
Darn it.
Oh, no.
All 3 of them have to work together. Are they like terms?
No.
No. It's 1, isn't it? Because in the first one, there are only x's. So you can't divide any y's out, can you? And in the second one, there are x's and y's, so you can divide out x and y, but wait a minute, you couldn't divide y out of the first one, so wait a minute, can't do that. And the last one only has y's, it doesn't have any x's, so these guys don't really get along at all. Their GCF is 1. So guess what?
Boy, that unique.
We don't even have to work at this one. We can say 3x squared plus 4xy
Is 1.
minus 2y squared cannot be factored by the GCF.
Cannot.
Doesn't mean it can't be factored another way, but we don't know how to do those ways yet. So we're not going to worry about those. We're just going to say it cannot be factored by the GCF. This is as good as it's going to get for right now until I know more.
Is that what's always going to happen if you have an x and a y together like that?
It depends on it. If each of the terms would both have x's and y's, then no. But if some of them have some of one and not the other, then that, yes, that would be possibly true. So you just gotta kind of go through the process we did. Can't divide y's out of x squared. Can't divide x's out of y squared, so there's no greatest common factor.